Today we're going to learn about unit circle trigonometry. The horizontal distance d in feet traveled by a projectile launched at an angle theta and with an initial speed v in feet per second is given by the relationship below. Estimate the horizontal distance traveled by a golf ball that is hit at an angle of 50 degrees with an initial speed of 105 feet per second. The initial speed is v, so plug in 105 for v, and the angle is 50, so plug in 50 for theta. Now use a calculator to solve. That's approximately 339 feet the ball has traveled. Recall those special right triangles, the 45-45-90 and 30-60-90. Fill in the angles in your special right triangles below. Remember, 45 degrees is pi fourths, 30 degrees is pi over 6, and 60 degrees is pi over 3. Fill in the side lengths and angles of the special right triangles below where the short side x is equal to 1. So the short side of your 45-45-90 is equal to 1. This is an isosceles right triangle, so both legs are 1. The hypotenuse is equal to the short leg times root 2, so 1 times root 2. That would be root 2. If the short side of the 30-60-90 degree triangle is 1, then the side across from the 60 degree angle will be 1 times root 3, and the hypotenuse will be 1 times 2. Complete the sides if the hypotenuse is 1. The relationship between the sides and the hypotenuse of a 45-45-90 is that the hypotenuse is root 2 times the leg. So if your hypotenuse is 1, how would you find the leg? It would be 1 divided by root 2. 1 over root 2. When you rationalize, that becomes root 2 over 2. If the hypotenuse of a 45-45-90 triangle is 1, then its legs are root 2 over 2. If the hypotenuse of a 30-60-90 triangle is 1, then the short side would be half of that, which is 1/2, and the side across from the 60 degree angle would be 1/2 times root 3. These are the values we use for the unit circle. If these triangles were built in quadrant 1, the point here at the top would be the horizontal distance, comma, the vertical distance, which would be root 2 over 2, comma, root 2 over 2. And for the 30-60-90 degree triangle, when 30 degrees is your angle at the origin, the point at the top of the triangle would be horizontal distance of root 3 over 2, comma, vertical distance of 1/2. Make sure you watch the unit circle video before moving on to how to find exact values of trigonometric functions using the unit circle. For part A, cosecant of 240 degrees. Cosecant is the reciprocal function for sine, so this would equal 1 over sine of 240 degrees. 240 degrees is equal to 4 pi thirds. Because sine corresponds with y, the y value at 4 pi thirds is negative root 3 over 2. Find its reciprocal, that would be negative 2 over root 3, and now you'll need to rationalize the denominator. Cosecant of 240 degrees is negative 2 root 3 over 3. Part B, sine of 315 degrees. Sine corresponds with the y value, and the y value at 315 degrees, equal to 7 pi fourths, would be negative root 2 over 2. Cotangent of negative 315 degrees. Cotangent is the reciprocal function to tangent, so this would equal 1 over tangent of negative 315. Negative 315 is the same as positive 45 degrees. Tangent of 45 degrees is 1. 1 over 1 is 1. For tangent of negative 930 degrees, that's multiple rotations. So I'm going to find a coterminal angle that is labeled on the unit circle. Add 360 degrees to negative 930 degrees. That's still more than a full rotation, so let's add 360 again. A coterminal angle would be negative 210 degrees. So tangent of negative 930 is the same as tangent of negative 210. Negative 210 is equivalent to 5 pi over 6, and tangent of that angle is negative root 3 over 3. For sine of negative 9 pi over 2, that's also multiple rotations. So let's add 2 pi to find a coterminal angle. Negative 5 pi over 2 is still more than a full rotation, so let's add 2 pi again. Sine of negative 9 pi over 2 is the same as sine of negative pi halves. The y value at negative pi halves is negative 1. Cosecant of negative 16 pi thirds. Let's find a coterminal angle. Negative 4 pi thirds is coterminal to negative 16 pi thirds. You could even add one more 2 pi to get a positive coterminal angle. Negative 4 pi thirds is the same as 2 pi thirds. Because cosecant is the reciprocal function of sine, I'm going to look at sine of negative 4 pi thirds, or sine of 2 pi thirds. Sine corresponds with the y value, so that's root 3 over 2. Find the reciprocal, rationalize the denominator, and cosecant of negative 16 pi over 3 is 2 root 3 over 3. For cotangent of pi, cotangent is the reciprocal function of tangent. So cotangent of pi is equal to 1 over tangent of pi. Tangent of pi is 0. So 1 over 0 is undefined because you can't divide by 0. Tangent of 5 pi. 5 pi is more than a full rotation, so let's find a coterminal angle by subtracting 2 pi. After doing that twice, I see that 5 pi is coterminal to pi. Tangent of 5 pi is equal to tangent of pi, which is 0. Cosine corresponds with the x value, so that would be negative root 2 over 2. For tangent of negative 13 pi over 4, add 2 pi to find a coterminal angle. I did it twice so we could find a positive coterminal angle. Tangent of 3 pi fourths is equal to tangent of negative 13 pi fourths, and that would be negative 1. For secant of 2 pi thirds, secant is the reciprocal function of cosine, so that would equal the reciprocal of whatever cosine of 2 pi thirds is. Cosine of 2 pi thirds is negative 1/2. The reciprocal of negative 1/2 is negative 2. Cosine of 7 pi over 6. Cosine corresponds with the x value, and that would be negative root 3 over 2. For cotangent of negative 7 pi over 6, I decided to find a positive coterminal angle, and that's 5 pi over 6. Because cotangent is the reciprocal function of tangent, cotangent of negative 7 pi over 6 is equal to 1 over tangent of 5 pi over 6. Tangent of 5 pi over 6 is negative root 3 over 3. So find the reciprocal, rationalize the denominator, and reduce. That would equal negative root 3. Sine of 7 pi fourths is conveniently already on our unit circle, and that would be negative root 2 over 2.